Friends, we were discussing about arrays and data structures in Python. Particularly, we continue more about Numpy arrays. This is very important for your scientific calculations and for big data handling. We have seen many different kinds of arrays. Now we can just check with complex arrays, means arrays with complex numbers. So before we begin, we will have to import Numpy. So import Numpy as np, and suppose this is the complex array. These elements are complex. So you can manipulate the data. That means you can extract the real numbers as x.real. So real is now an attribute to the x. X is now Numpy array. So if you type that, it will show you the real numbers. So if you write x.imag, so it will give you imaginary numbers, imaginary parts. If you write another attribute x.conj, conjugate, this is a function, so you will get conjugate these things, and easily you can multiply with this, and of course you will get the square of those, absolute square. Okay, so we can do basic statistics over Numpy arrays. Suppose this is a Numpy array you create with a range. That means it will start from 10, go up to 100, but it won't touch 100, and the step size is 10. As you know, this a range is the number creator in Python, in Numpy. So if you write np.sumx, this will calculate the sum of the numbers. Of course, this is here as a one-dimensional array, so it's no problem. It will just sum all the numbers, 450. If you write cumsum is cumulative sum. So it becomes 10, and then 10 plus 20 is 30. Then 10 plus 20 plus 30 is up to 60, and so on. So it is cumulative sum. So this is this. If you take another array, so the array, the same array, you now convert this into you reshape this into a 3x3 array. So that means it is a two-dimensional array now. So array will look like this. So the array will have now 3 rows and 3 columns because you have reshaped it as 3x3. So now remember this array. It has 3 rows and 3 columns, 10, 20, 30 first row, then second row, then third row. You remember this. Now, if you now take the sum of this array, but now the array is two-dimensional, so instead of just pair sum, you now have to tell in which axis you will sum. If you now say np.sum x, 0, that means you are actually trying to sum on the 0 axis. What is 0 axis? 0 axis is in this direction. Remember again, go back. So this is 0 axis. So you come down this way. That means if you take the sum x, 0, that means it will come down this. That means it will take the sum of these 3 numbers. Then it will take the sum of these 3 numbers. Then it will take the sum of these 3 numbers. So let's see that. So this is this 120, 150, and 180. Now if you sum along the one axis means it is on the horizontal. So you go by one row. So the sums will be sum of the first row, sum of the second row, sum of the third row. So this is one axis. Now if you say x.sum 0, so it will give you the same thing. Like either you write np.sum in bracket x, 0, or you write x.sum in bracket 0. In this, this is the alternative forms, because x is now the Numpy array. So you don't have to write numpy here. X is already numpy, and dot sum is now an attribute, and you put 0 inside in the argument, so that this 0 signifies that the sum will be on 0 axis. That means along this direction, column wise. Now similarly, if you write x dot sum 1, it will give you the same result. So either you write this way or you write this way. This is your choice. Now remember the array again. So now if you want to take trace is, we know that trace of a matrix is the sum of the diagonal elements. So if you now take the trace, np dot trace in bracket x, although it is not typically a matrix, but it looks like matrix. Why it is not matrix? It is a two-dimensional array, because matrix has certain other properties. You know, the matrix multiplication is something very peculiar. So anyway, so if you now take the trace, so it is 10 plus 50 plus 90, so it is 150. Now you can also take the trace in bracket, you write x comma 1. Here is 1 is not axis, but it is the trace of the first diagonal, upper diagonal. So the trace will be, if you write np dot trace x comma 1, so the trace will be 20 plus 60 equal to 80. So this is this trace x1. So 20, 60, 1. Now also if you write np dot trace x comma minus 1, that means it is the lower diagonal. So it will be 80 plus 40 equal to 120. So it is the lower diagonal. So also you can write, if you write trace x comma 2, that means it will be 30. If you write trace x comma minus 2, so then it will be this. So the 1, 2, 3 this way, minus 1, minus 2, minus 3 this way. Okay. So if you now write mean, so mean is another method, another in NumPy. So applied on this X array. So similarly, it will be the mean of all the numbers, since you have not referred any axis here. So mean of all the numbers in the array. But if you write mean x comma 1, then of course the 1 will be the axis reference. So it will be the mean of the 1 means on the this way, right? And the mean x comma 0, 0 means it will come along this way, vertical direction. That means along for each the mean of each column. So this is the mean of each corresponding columns, because it is 0. 0 means you come down, and 1 means you go this way, right side. So these are the means of each row, and these are the means of each column. So now in the same way, you have median. Median means what? You take a set of numbers and you arrange them in order, then it is the number in the middle. It is the median. So the numbers mean is 50, because if you go back, look at the array here. So if you take the median of all the numbers 10, 20, 30, 40, 50, 60, 70, 80, 90, so these are all ordered already. So the mean is the 50. But if you take the mean of these three numbers, of course the mean will be 40. If you take these three numbers 10, 20, 30, mean will be 20. So this way this is the median. Median will be this, of course. Okay, not mean, median. So median will be the middle one. So if you now write np dot median x comma 0, so of course it is on the this vertical axis. So 40, first column, mean of the first column, mean of the second column, mean of the third column. Similarly, if you write x comma 1, so the median will be of the first row, median of the second row, median of the third row. Well, now consider this array where you have certain numbers, negative and some positive numbers. So now you write np.ptpx. PTP means peak to peak. Often you use when people who deal with electrical signals, they know they want to know the peak-to-peak value of the signal. Suppose you have a sinusoidal wave, so it is the positive highest and the negative the lowest. So the difference between the highest and lowest, so that is the peak-to-peak value. So since these are the numbers, you know the lowest is -2 and the highest is 10. So of course the peak-to-peak will be this minus this number. So of course the peak-to-peak value will be 12. Now if you write variance, variance means you know you have calculated variance and standard deviations. That means you will have to calculate the mean and take the difference of each number from the mean. Then you take the squares and then sum and then average. Okay, so that will be the variance. So this is np.var. So it will calculate the variance of all those numbers. Well, if you now calculate tell np.std, standard deviation. Standard deviation is nothing but the square root of this variance. So standard deviation of all those numbers, it will be this. Okay, so this way, suppose you take these same numbers, okay, that you considered earlier, and now you reshape this in 2x4 matrix, 2x4 arrays. So x is now this. Now in the same way, if you write np.ptp x, 0, that means 0 means in this direction. So the peak to peak will be on this column, on this column, on this column, and on this column. So the peak to peak of this column will be, of course, 10. Peak to peak of this column will be 3 minus 1, that means 4. It will be 4. It will be the 5 minus 4 equal to 1. Now if you try to write ptp x, 1, that means peak to peak value of this row. It will be 5 minus 1, that means 6, and it will be 4 minus 2, that will be 12. So that way, for every method like mean, median, then PTP, then standard deviation, STD, variance, whatever you calculate, sum, cum sum, all the methods you calculate. For every method, you can put in the argument inside, you can put the axis. So that way, you can take these things, this method, you can apply these methods over a particular axis. And this is for two-dimensional array. You can now, if you now have to calculate the same things and to refer the axis for the three-dimensional arrays, then the arrays will be 0, 1, 2. Similarly, you can extend the idea and you can get the references of axis for 0, 1, 2, 3, 4, etc., etc. More than 3 dimension, of course, you cannot visualize. In fact, more than 2 dimension here in this, it is difficult to even think. Okay, more than 3 dimension is okay, but more than 3 dimension data you cannot visualize, but you can think in terms of the axis. So whatever you do for a higher dimensional data, for ND arrays, n-dimensional arrays, so you have to refer the axis properly so that the particular method will be applied on the particular axis. So this, and now you do this sorting. So suppose you take I created some numbers through random number generators. Random is a module, random number module in Numpy, np.random, and in that I used randint as a function. This is a function. Randint means it will create random integers, and it will create random integers between -10 to +10, and all those numbers, how many numbers? It will create an array of 4 by 5. So if I write this is the shape. So if I write this, so these random numbers came randomly between -10 to +10, and all these numbers are in 4 by 5 arrays. So now you sort all those numbers of the arrays. So apply this in np.sort. Sort is again another method, applied on L. So it will, what it will do, it will basically it has done not all the numbers. See, you have not reference given the reference, you have not given the reference of axis, but you see what it has done. It has actually ordered each row separately. See, it is -7, -6, -4, 5, 6. So it is in the ascending order. Then the next array, next row, it is -9, -8, -4, -1, 0. Then the third row, it is -5, 0, 0 to 8, and so on. So in this, without the axis reference, it has actually by default, it has sorted the numbers in ascending order for each row. So you can take write help, and inside that you can write np.sort, and you can see what are the arguments it takes. I have not given any other argument here. So actually it has ordered in this direction. So basically along the one axis it has done by default. So you have to check before using a method, you have to check what it does by default actually. So if you write L, 0, then you see it has ordered in the column direction, because 0 is in this direction. So it is it has ordered -8 to this, -9, -5, -4, 8. So each column it has ordered. And if you write np.sort L, 1, so that is by default what you did, np.sort without this reference. So you can see now this is along the this each row. Okay, now the last thing is concatenation. Concatenation means in the list method you have seen that if you add two lists, the lists are concatenated, means one is added at the end of the other. So now in the Numpy array you cannot do that because Numpy arrays are vectorized. So vectorized means if you try to add two arrays x and y, I will show it in later video, that it will actually add 10 plus 40, 20 plus 50, 30 plus 60, and so on. So to concatenate, you have to use the function here, concatenate. So np.concatenate, that is a method, and inside that you have to write which will be concatenated with the other. So x and y, first x and then y, and then you put this in the form of a tuple. So this is the concatenated array, 10, 20, 30, the first row, first array, and then the 40, 50, 60, second array. Okay, now if you have x is like this and y is like this, and you can understand this x and y are two-dimensional arrays. So if you now try to concatenate x and y in the same way, right? So of course the first array is this, and then below that this is the second array. Okay, now if you write np.concatenate x, y, and you now refer axis again, axis equal to 1, that means it will concatenate along this horizontal axis, and that means along this along this row direction, this direction, horizontal direction. So this is the first array and this is the second array, and this is actually by default this is axis equal to 0. Okay, so this is the end of part